This week's video is about Wordle, BASIC, and 8-bit computers. It's based off a great tweet from one Katie Anderson, Katie_Panda on Twitter, who wrote a basic version of Wordle for the BBC microcomputer, and then went so far as to make a program listing for it, in the style of the old game listings from Creative Computing. For those of you too young to remember this, in the late 1970s and early 1980s, one of the most popular ways of distributing programs wasn't on disk or even cassette tape, but just paper. Magazines would have program listings in them, sometimes very, very long program listings, and you would type them into your computer, run them, probably save them to cassette or disk yourself. Katie went to the trouble of making this BBC micro game, so today we're going to type her listing into an Apple II and see if it works. When you're transcribing a game like this, there are three main types of errors. First, sometimes you'll simply type something in wrong. Second, sometimes the programs in the magazine themselves would have typos. And third, sometimes the program would be written for a computer other than the one you're using. And so the commands for that computer wouldn't work the same on yours. The dialect of BASIC might actually be different. Today, I can almost promise you that we will see all three of these sorts of errors. The fun part, though, is that it was the process of encountering and fixing these errors that gave a lot of people their start in programming. Typing in a program is definitely a ponderous way to get your start in computers, but it's actually a surprisingly effective way to learn. Let's hop over to the Apple II and get to work. All right, so here we are at our basic prompt, and I apologize, you're going to hear my keyboard sounds while I type. It's part of the experience. We can see we have nothing in memory right now, so let's get to work typing in Katie's program. I am going to skip some of the boilerplate, like the instructions for most of the game, but because I want to make this a reasonably short video. And I may also accelerate or fast forward past some of the more uneventful parts. Let's see how it goes. So first, we're going to immediately have a line of code that I promise you won't work on the Apple II. This mode 0 tells the BBC Micro to be in, I believe, to be in a text mode. I was never a big BBC Micro user. I never had one. I haven't programmed it. But from searching on the internet, that's what this seems to do. So we're just going to leave that line out. And we might not normally find that out until we typed in the entire program. But let's see how it goes. So first thing Katie does is she prints a title and some instructions. Now, the BBC Micro had a wider display than the Apple II, so that tab 33 is probably too far over. Oh, that should be a semicolon, not a colon. My eyes are pretty bad, honestly. All right, so Wordle is too far over. So what do you do if you make a mistake when you're typing in a program back in the day? Well, of course, you might be a fancy programmer and using a screen editor of some sort, but I was a kid when I was using this, and I certainly wasn't doing that. One thing you might do is what I did when I made this mistake here, which is just type the line over again. The other thing you could do is use the cursor keys. I'm hitting Escape D to move up, and then the arrow key to move over. And then let's say, let's try 22 and see how that looks. Go all the way to the end of the line here and run it again. Still a little too far over. I'm not going to worry about that. Let's go on. So there's about 10 more lines of instructions for how to play the game that I'm going to skip. And around line 65 here is where things start. So we set aside some space for some variables, probably strings. I've already made typos, and typos were very common when you're typing in from a magazine. The read command is going to access inline data that will define at the very end of this program. That's going to be the word list. So we're going to generate a random number, and that random number line is going to be, I'll tell you, it's going to be something we're going to have to change because the random number function on the BBC Micro and on the Apple II worked differently in their version of BASIC, I should say. And this is AppleSoft BASIC on the Apple. There were several variants. We've got a loop here where just clearing things out looks like, putting a bunch of spaces in. And if someone has typed in too many characters, it looks like, complain about them. K is, I guess, a special input. Right, type K to see the alphabet. So this version of Wordle does not show you the alphabet grid unless you explicitly ask for it. So I also think, I can't remember, I thought that Apple II if statements needed a then, but I guess we'll see. We'll go ahead and see how that goes. If the word that's been typed in is not 5, now you may see things that I'm typing wrong as I type them, and well, that's going to be frustrating for you. I'm not going to really find them at this point until I actually run the program. So we've got some stuff here. Let's see. Looks like we've got another for loop coming up. We're going to be looping through the 5 letters that have been typed in. Got a new string and we're just setting it to X. Not sure what that's for yet. And here we're doing some comparisons, probably between the word that the player typed in and the word read in from the word list. So if the letter matches, we're going to be printing an exclamation point. Great. We're going to initialize some variables here, and wow, I was off by my hands were in the wrong position there. Really typed that wrong. But we're clearing out some variables, it looks like, initializing them. Another loop. Another comparison. Mid $, in most variants of Microsoft BASIC that I knew of, it's kind of a substring operator. And what you would do, by the way, when you're typing these things in, you see these things. If you've never used them before, you don't know what they do. And what you would do was you would get your BASIC reference manual. Most computers back then came with BASIC as kind of the default lingua franca of the computer, and they'd come with manuals. Some of them were very, very simple, basic, if you'll pardon the pun. Some of them were more advanced. The Apple II came with a basic reference manual that was not too dense. Even a kid could read it. And you'd look up, you say, what is this mid $ thing? And you'd look it up and understand what it does. Hopefully. Another loop over 5 characters and another comparison. I have the caps lock key enabled, as you can imagine, but out of force of habit, I'm sitting here with my hand kind of jammed on the shift key just because I'm not used to ever using caps lock. So it's probably where a number of my typos are going to come from. See, there's a then. Okay. Yeah, this is pretty dense. I'm not entirely sure what exactly this code is doing, but I think it'll become apparent as we run it and find the mistakes we made. You get into kind of a Zen state. Semicolon after the print statement means don't print a new line. It's probably one of the first tricks many kids learned in the classic program to print your name a billion times on screen, or more like 20 times because the screens were pretty small. This next command is the termination of a loop. So a loop in BASIC, you're going to say for something to something, and then when you get to next, you're going to jump back to the top of the loop. I've left some extra spaces in here accidentally. Those are, I believe, that those shouldn't matter. I don't think they're syntactically important. Okay, and then here I think we're actually printing the results. Oh, I see. No, this is printing which of the characters have been used. Okay, 550. Okay, we're getting close to the end here. We have some scoring logic. Her scores are very positive. They really boost the user's spirits, which I approve of. I think we could use more positivity right about now. This is, I believe, our victory screen. Oops, that should be 626. Why am I reading that as 5? I think I cut this off on my screen a little too tightly. The secret word was, okay, so now we know that S string is the secret word, or S $. Wow, I messed that one up. Let's just retype that line. Right. Do you want to play again? Y/n, and then we call the input routine to get the response. If the response is Y, then restore is a command which is going to reset our reading of the data, which we're almost at the data, so you'll see that momentarily. And then we've got our data. So here's another place where I have to deviate from what Katie has. So she ends her program listing with a joke. That's kind of a joke, in that it's the inline data of all the words that might appear in Wordle, which of course there are thousands of them. In fact, we know how many there are because the very first line of the data is, the very first item in the data is how many words there are. And there are 2,315 words, and her program listing does not include all of them. But I promise you, if this program was actually in creative computing, you would get to the end of this page and it would say, turn to page 423, and then all 2,000 words would just continue on in those listings. And yes, you, as a computer-obsessed 10-year-old, would absolutely try to type all of those words in. So we were going to have to come back and change this 2315, but for right now, let's stick with it and we'll see what type of error we get. And I'm just going to type in, I think, 2 lines of these words. Okay, data is an interesting meta instruction in BASIC. It can appear anywhere in the program, or data lines can appear anywhere in the program. They are always used in the order in which they appear. They don't have to be contiguous. The execution of the program treats them as no ops. The only thing that really affects them is that read statement. And read will start at the very first item in the very first data line it finds, and then increment itself as you read. And then restore will kind of reset that pointer. All right, so we now have an entire program listing. We can look at it. I'm confident this is not going to work when we type run, but let's see what type of errors we get. Okay, we got further than I thought. We're being asked to type in a word. So let's type in a word we know is not there. Okay, let's do hatch. That's a 5-letter word. You know what? First, let's do a non-5-letter word. Let's say benches. I could have done hatches, I guess. Okay, we immediately hit a syntax error. That's good. We know what line it's in. We can look at that line of code. All right. And I can tell you that I believe that what's going on here is exactly what I said before, which is that this needs a then after this if statement. Okay, we'll try it again. We got our error, and we're going back to being asked to type in other words. Let's do bench. That one is 5 letters, and okay, so now that was very interesting. We got suggest to us that the C is correct, but something else is not correct. Well, let's try another word. Okay, we know that the AB is correct. And cheating a little bit, the very first word in our data line was aback. The secret word was aback. Would you like to play again? Well, not right now. So we can see we have a few little buglets here. Let's take a look at one of them. I think we just need a space here to make this print correctly. Okay. Well, that was okay. Let's run it again. Let's try it one more time. Well, let's just guess aback like we did last time. Apparently, I'm a genius. The secret word was aback again. What are the chances? Well, you know what? We only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 words. So 1 out of 11 chance. I mean, aback could come up more than once in a row. Uh-oh. I'm getting a very Rosencrantz and Guildenstern feeling from this. So, of course, we can see we are choosing the word aback every single time. And that is, as I said earlier, as I alluded to, because the random function is different. So let's look at the program listing on line 80 there. So the RND function, if we look at the AppleSoft Basic reference, generates a number between 0 and 1. So I actually don't even know what this line is doing in this case when we have probably a floating point number as the second argument to this for loop. So I think this needs to look more like this. We want to make it an integer, and we want a random number, and it should be positive, and C is positive for various reasons. And then we're going to multiply it by C. C was the first item in our data list, which in this case is 2315. So I got all the parentheses matched. I think I do. Hopefully I remembered that correctly. Well, let's run it and see what happens. Out of data error. So this gets to that question. That C value was 2315. And as I said, I don't think we have, well, I know we don't have 2,300 words. We have, let's see, 11 words. See if it wants 11 or 10. I don't know if this is 0 or 1 indexed. Let's try it. Let's go for a back. It is not a back. It is an AB word, but as we said, there are not a lot of choices here. It's not abide. Wouldn't be abode. Okay, so the question mark I think means that that O is in the word, but not in that third position. Could it be abhor? That was it. So this was Wordle. Katie, I think you did a great job. I thought it was, and I don't think Katie wrote this thinking people are going to run the program. I don't know her intention. I should ask. But I think a lot of it was just for the visual joke of this thing being a magazine listing. And the truth is, I think a lot of people have a lot of fond memories of those magazine listings, but beyond the fond memories, I want to say these are actually clever ways to learn programming by doing. Are they going to turn you into a professional? Would they have done that back then? No, probably not. But they are vectors. They were vectors in to this kind of very, very orderly way of thinking. You know what? Let's save this program because we put so much effort into it. I want to be able to load it again and run it. And maybe, who knows, maybe I'll actually someday type in those 2,315 words. This has been Programming Like It's 1979. Thanks for watching.